This is the second video out of 10 for the tutorials that describe setting up the simplest simulation with numerical software. In this part, I show how we introduce variables that we are going to use for setting up objects in the simulation domain. The structure we are going to simulate was discussed in the previous video. I would like to remind you that I provide PowerPoint slides supplemental to this video tutorial. We start by launching Lumerical software. Next, we go to Product, New. We select a section called FDTD, which stands for the finite difference time domain. This is basically the template. In contrast to CST, there are not many selections. This is a workspace for the structure we are going to work with. Let me outline the main parts of the workspace. First, we are going to have this setting tree. Different elements are going to appear in this setting tree down here. Second, we have this top panel with different sections. We are going to use this panel to set up structure objects such as non-antenna, as well as excitation source, field monitor, and so on. Later, after the simulation are completed, we are going to look at the results, and we are going to use the tree down here. Now let me introduce the procedure and conventional approach. Similar to other packages, we right-click on whatever object we are going to work with. For example, we select model, and then we choose edit object. Make sure that here we look at the setup and variables tabs. This is a place where we introduce variables that we are going to use in the setting up our simulation. We click add. It appears as a new line here for each new variable. We are going to discuss the dimensions and coordinates of the structure object and simulation elements. We select length for the type and give it some value. There is also an option to define the dimension of this variable, and it's going to be microns in our case. Let me introduce all variables that we are going to work with, and then we will continue setting up the structure using all these variables. We need variables for the structure period in the x and y directions. It is dx and dy respectively. Dx is 0.22 and dy is 0.35 microns. We need to define the sphere radius, and it's going to be a variable called SPH radius. And the value is 0.065 micron. These are three geometrical parameters of the structure. Further, we need to introduce parameters that define simulation domain characteristics. For example, h top is the distance between the substrate and the top boundary of the simulation domain. In other words, it is the thickness of the superstrate. If the object such as non-antenna is surrounded by a homogeneous environment, this is the distance between the bottom edge of the non-antenna and the top boundary of the simulation domain. We set this distance as 1 micron. Similar, we define edge bottom which is the thickness of the substrate, and again, it is a 1 micron. Then we also need two other characteristics related to the light excitation source and detection monitor. I'm going to call the first one H source. It is a distance between the light source and the non-antenna. We place the source right before the end of the domain. We give that variable H source a positive value, and it is up to be slightly smaller than 1 micron, in particular 0.99 micron. Another variable is the Z position of the detection monitor. We also set the detection monitor to be right before the end of the domain. However, we place it on the opposite side from the excitation source because we aim to find the transmission coefficient. So we give that variable H monitor a negative value, and we set its absolute value slightly smaller than 1 micron, that is 0.95 micron. It will also be convenient if we define the coordinate origin we are going to use. We set X origin, Y origin, Z origin as 0. At this point, we entered all variables that we need as parameters in setting up our simulation. As always, it's important to save the project regularly. Any software, especially one that runs multi-purpose simulation, can crash anytime. Even high quality and very stable commercial packages crash from time to time, especially when we launch the simulation. It's important that project settings are set and we do not lose the changes that we have made. This completes the second video on the numerical simulation with the Lumerical FDTD tool.